VLSM, Variable Length Subnet Mask, or sometimes known as subnetting a subnet. A VLSM, also known as a classless Internet Protocol, is a numerical masking sequence or IP address subnet based on overall network requirements. This type of addressing allows network administrators to use long masks for networks with few hosts and short masks for networks with multiple hosts. A router must support VLSM for this protocol to be deployed. Some of the key features with VLSM are simple network configurations, network IP addressing through empty subnet filling, greater efficiency than fixed-length subnet masks, and streamlined routing where a router functions only with a VLSM sequence versus a full IP address. Some of the systems that use VLSM are the Intermediate System to Intermediate System, or ISIS, the Border Gateway Protocol, BGP, the Enhanced Interior Gateway Routing Protocol, EIGRP, or Cisco's Open Shortest Path First, which is the OSPF. Now, you may ask if there is a difference between VLSM and CIDR. Well, technically, CIDR is a process that allows communication of classless subnets, whereas VLSM allows you to define these classless subnets so they can be exchanged by the routers. CIDR is based on VLSM, which allows the network to be divided into different sized subnets. As said, you can think of VLSM as subnetting a subnet. VLSM uses CIDR notation to describe the networks using the prefix and the suffix indicating the number of bits in the network portion of the address, such as 172.16.25.0/24. Okay, let's go ahead and move on to some examples of how to configure a VLSM network.
For our example here, we have 4 locations, A, B, C, and D. Each one of these 4 locations is connected via the Internet. Our first requirement is to find out exactly how many hosts are needed and what our IP addressing scheme should be. In this case, we start with the highest number of hosts needed, in this case, location A with 126 hosts, followed by location B with 62 hosts, and then location C and D both needing 30 hosts. Now, with that being said, we have to remember the connections in between these 3 Internet connections are all going to require 2 IP addresses each. So let's go ahead and work this problem out. Again, we will start with the highest number of hosts needed. Okay, our problem here, we are working with a Class C address. In this case, we're going to focus on just the last octet in this Class C address, the last 8 bits in that last octet, just to make things a little bit simpler. And also, as said, we start with the largest number of hosts needed, which in this case is 126. So what we need to do is we need to find out somewhere in this range where we can get 126 usable hosts. Obviously 64 it's non-doable. 128 will work though. We can get 126 usable hosts out of 128 hosts in this address here, keeping in mind that we have to reserve the subnet address and the broadcast address, or the network address and the broadcast address. Taking those 2 bits out of the 128 will leave us 126 usable hosts. So, and 128 also provides us with 2 subnets, and to find out how many subnets you can get from an address, you take whichever host, in this case 128, and you take 256 and you divide it by, in this case, 128, and that gives us 2. With 64, just as an example, you take 256 divided by 64, and that gives us 4 subnets that you can get from that address. And again, let's take it one step further, 256 divided by 32, and this will give you 8 subnets that you can get from this address. So that's where that pattern comes from. But going back to our problem here, since we are going to use 128 for our particular requirement here, this will give us a range of 0 to 127 for the first subnet, and 128 through 255 for the second subnet. So therefore, this 126 range will fall into this top group here, minus the network address and the broadcast address. So that'll give us a range of 192.168.10.1 to 192.168.10.126. Okay, now this are the number of IP addresses they can assign to their particular host. This also will have a subnet mask of 128. So their subnet mask, class C again, is going to be 255.255.255.128. Okay, now that completes the first requirement for the 126 host. Let's go ahead and move on now to the host of 62. Okay, let's go ahead and work the next location that needs the 62 addresses. Again, we go to our host here and see where the 62 will fit in nicely. Obviously, it'll fit into 128, but that's a little overkill, so let's go down one. 64. It'll fit into the 64 with 2 to spare again for our subnet address and our network address, or broadcast address it is. So, with that being said, 64 will give us 4 subnets itself. So let's go ahead and work that out. It's 0 to 63, 64 to 127, 128 through 191, 192 to 255. Okay, that's our 4 subnets that we can get from this particular address here. So 62 will obviously fit into this first range here, and as with the other one too, it gives us room to grow too, but it at the same time does not waste IP addresses. So with this being said, this being our subnet itself, and this is our broadcast address is 0 and 63, our range for this particular host requiring the 62 will be 192.168.10.1 to 192.168.10.62. Now, the 1 to 62, that's how many hosts they can assign addresses to out of this subnet. This also will have a subnet mask of 255, 255, 255, and right here is 64. You go down to the subnet is 192, so it'd be a subnet mask of 192, and that gives us our second requirement here. We've met that requirement. Now we have to work down through the rest of these, and you probably know, so I've got 2 here that have both the same number of required hosts, and 3 here requiring the same number of hosts. So you're probably wondering, that's going to be confusing, how it's going to work. It's really not that difficult, and let's go ahead and proceed, and I'll show you how to work this out. Okay, now we're down to our 2 locations needing 30 hosts, usable hosts each here, and this looks like it's going to be a challenge, but really it's not. What we basically do is go the same route. We figured out from our host range up here where we can get 30 usable hosts. Obviously 128 and 64 is a little overkill. 32 is our next best bet, again leaving us our broadcast and our network address. So we take those 2 out, take the 2 from 32, we do have 30, so we have 30 usable hosts each. Now, this is going to actually give us 8 different networks here, the 32, and this is going to be 0 to 31, 32 to 63, 64 to 95, 96 to 127. Kind of had a brain fart there. We'll just stop there because that's basically where we need to go, because this gives us 2 subnets, this gives us 4, this gives us 8. Basically you can do the numerics and come up to 255, but since we only need 2 of them, I'm just going to stop there. So what this will do, the first one can fit into this subnet, the first subnet here, and this one could fit into the second subnet. That's how it works. So this first one right here is going to be 192.168.10.1. Again, the first and the last host address or bits those are reserved, so we can't use those. And this is going to be 192.168.10.62 with a subnet mask of 255, 255, 255, and looking at here, 32 falls under this category, the 224, be 224. Okay, that's going to be this guy right here. Now, this one right here is going to be, their range will be coming out of this second subnet right here. So this range will be 192.168.10.33 to 192.168.10.62 with a subnet mask of the same here. It's going to be 255, 255, 255, 224. Okay, now that's how you work a problem if you have two locations needing the identical number of hosts. And with that being said, we'll work our last three coming up here, and this process is no different than working with two. So let's go ahead and work this last part here. These will be the internet connections between all the different hosts. Okay, we're down to the final stretch here. We're having to figure out the IP addressing for the internet connections between our four separate hosts. We can see that we need two usable hosts for each connection. Our eyes focus immediately on this number 2 here, which is not going to work because remember your rule, 2n, or 2h in this case, minus 2, and that gives you how many hosts you need here. Obviously, you have to subtract this 2 right here, so if you subtract 2 from 2, you're going to have 0. Obviously not going to work. Therefore, let's just bump it up 1 to the 4. So we can do that because 4 minus the 2, the network and the broadcast address, gives us 2 usable hosts. So with that being said, and I'm not going to go and list everything down as far as how many subnets you can get from this particular address here because it's far too many to write down here and be wasting time. I'm just going to put down a few of them here. So our host, the number of hosts we can get here, the first one's going to be 0 to 3, then 4 to 7, then 8 to 11, 12 to 15, and we'll say, I'll take one more, 16 to 19. Okay, and it goes all the way down to, you come to whatever, 255. But since we only need these 3 right now, and this may look like we're wasting addresses, but we're not wasting any IP addresses at all. It's not like you can't go in and use different subnets after this. When we're talking about wasting addresses, basically, we're talking about, let's say you had a host range, and this has nothing to do with this address, but let's say you had a host range of 0 to 31. Let's say this would be a 32 selection here. If you were to only use 1 to 4 out of this range right here, and the rest of them you could not use, that's what is known as wasting addresses. But in this case, we're using pretty much, in fact, we'll be using every usable range in each one of these up to where we need to stop. But these are left over where you could use them for another application. Okay, let's get back to what we're doing here. Okay, with the first one, the first connection, 2 usable addresses, so we can take this from the first subnet here. We've got 3 subnets here, 1, 2, and 3 that I'm focusing on here. Let's go ahead and use this first connection out of that first subnet here. That will give us an IP address range of 192.168.10.1 to 192.168.10.32. 10.2, and that will be the first one. And I'll discuss the subnet mask in just a minute. The second connection, we'll use our second subnet. So this will be 192.168.10.5 to 192.168.10.6. Okay? Our third internet connection down here, two usables, will come out of that third subnet that we've got here, which will be 192.168.10.9 to 192.168.10.10. I think you can follow the pattern here. Now, we used the 4 hosts here, and that will give us, with this bottom number here, a 252 subnet address. So all 3 of these will have a subnet address of 255, 255.252. As you can see, each IP address is unique in itself, but with the same subnet address. And again, these are not wasted all the way from 12 all the way to 255 are not wasted. You can use those in other applications, other internet connections, anything that you might need just 2 IP addresses for. Now, this pretty much sums up the Vlsm example here. There's one last thing I'd like to cover, which was brought to me as a suggestion because I was questioning where these 128, 192, 224, and all this down here, this category goes or comes from for the subnet mask. Well, let me go ahead and clear this up, and then I'll focus on that and show you how I came up with those numbers. I was asked recently where I came up with the last octet for the subnet mask, the either 128, 192, whatever. And it's really quite simple. All you have to do, and this is valid for any of the octets in an IP4 address. Okay, let's just start with the 128. Simple, drop it down. The subnet mask in this case is going to be 255. This is the default subnet mask for a Class C address. I'm just going to focus on the Class C at this point. Now, where I got the 128 from, you just drop down the 128. And there's your 128 address. Now, that sounds simple, so just drop down the rest of them, right? No, it doesn't work that way. Now, to get to the next one, which is 192, right here, what you do is you take this 128 and you add 64. There's your 192. Now, to get to the next digit over, the 224, you take the 192 and you add the 32. There's your 224. Obviously, next one over is 240. To get that, you take your 224 and add 16. There's your 240. I think you follow the pattern here. Next one is 8. 248. And 4. 252. 252 and 2. It's 254. 254 and 1. And I'm not even going, well, what the heck. 255. So that's how you get the subnet last octet, or the octet. It may not be the last octet depending on what class you're working at. In this case, like I said, I'm just using Class C as an example. But that's how you get these subnet mask numbers down here, just by starting with 128 in the far left bit of whatever octet you're working from, and adding the number of hosts to each one to come to your final score of 255. Okay, I hope this has helped out some. If you have any questions, just drop me a line at steve@packetbyte.com. Thank you for watching.